Hello everybody. So today we have subtracting rational numbers. It says jot down the process for subtracting fractions and decimals. So when we're subtracting fractions, you have to find the least common denominator, subtract the numerator, and keep the denominator the same. For decimals, you got to line up the decimals and insert placeholders if needed. So when we are subtracting, we will use additive inverse to add the opposite, and then follow the rules for adding integers. So we are going to be subtracting integers here, but we're going to rewrite the problem to add the opposite and then follow the rules for adding integers. So additive inverse looks a lot like this, 7 plus negative 16, because this is a 7 positive 7 right here, and it's combining with a negative 16. So I always like to subtract integers in this way, okay? But if you were going to look back and follow the rules for adding integers, I'm just going to go back a little bit here. All right. It was from this part of the video. If the signs are the same, add and use the same sign. Okay, but if the signs are different, you can take the sign of the number with the greatest absolute value. So, for example, negative 2 plus 10, okay, you can subtract and then keep the number with the higher sign. So you could have negative 2 plus 10, right? You could subtract those numbers. So you could take 10, you could take 2 away from 10 and then keep a positive 8. Or you can do it a lot like this. This is additive inverse right here. Okay? You could subtract 17 from 8, right? But then you're going to have a negative sign. So I always just like to do additive inverse. And if you notice, for this one, negative 8 plus negative 11, you have two negatives, so your answer will be negative. You have a negative, and you are getting more negative. But down below here, for example, we have negative 2 take away a negative 10, so this is going to be adding right here. So I did a couple of those examples. So this example right here is a lot like this one right here. And then we have negative 9 take away negative 14. Notice I kept the negative in the front. Nothing changed there. But since I was taking away a negative, it becomes positive on this side, which is a lot like the next two problems you have to do right here. So then we have subtracting decimals. You need to rewrite the problem and add the opposite, then follow the rules for adding rationals. And it's very similar to the top as well. And I just made a few notes here so you can see them on the page. It says if the signs are the same, add and use the same sign. So you could add these numbers together, for example, negative 2.9 and negative 1.6. If I could add those together, so I could say, Alexa, what is 2.9 plus 1.6?
2.9 plus 1.6 is 4.5.
And now notice it was a positive, but I could keep the sign, so it would be negative 4.5. Okay? But then if the signs are different, subtract and take the sign of the number with the greatest value. Okay? So you're going to want to subtract and then take the number with the greatest value. So for example, 16.5 take away 12.4, you have a positive number. That's the larger number. That's got the large, so it's going to be positive right there. All right, but for example, on this one, you had 4.5 take away 6.3. So if they're different signs, you need to subtract. So I'm subtracting here. I'm subtracting here. For this one, you do know that these are going to become positives. Okay, so this is not really 9.2, but it is going to be 9.2 plus 7.4. Sorry, it's this one. Oh, it won't let me do it. But I tell you what, let me see if I can do it this way. So you would have a plus sign there, as well as this. And the same thing over here as well. These are plus signs. All right, and the same thing here. All right, those are just a few examples for you. All right, so then we have the process for fractions is the same. It just requires more steps. So again, it's going to be very similar to the top, and I've highlighted them down for you down below. If the signs are the same, add and use the same sign. So you have negative 3/10 and negative 9/10. I could add this together to give me 12/10, right? So I could have 12/10 here. All right. Now I added them together, but now I need to keep the same sign. So I'm going to keep it to be negative. For the sake of time, I'm not doing a fraction symbol. I'll just write it in. A little fraction symbol for you there. All right, I added those numbers together because they had the same sign, and I just keep the sign that's there. All right, that's for your blue ones right there. But if the signs are different, subtract and take the sign of the number with the greatest absolute value. So if you were going to subtract these, right, you would need to take the negative sign here because it is the greatest absolute value. If you don't know what absolute value is, it is the distance it is from 0, okay? And you need to go back and review videos on absolute value or look at that up on YouTube. So then we have fractions with unlike denominators. You define the common denominator, rewrite the problem to add the opposite, then follow the rules for adding. So you need to keep the denominator the same, okay? But I did convert these for you to give you common denominators. All right, just remember that if you have -1 take away, if you have a -1 plus a -4, that's going to be more negative. So, for example, you would have a -5 over 6. Okay, I think that's going to be it for today. All right, if you have any questions, feel free to email me. Okay, and feel free to look up any of these topics over here on the side on YouTube: fractions with unlike denominators, fractions with like denominators, subtracting decimals, or subtracting integers. Okay, you can look up any of these topics on YouTube. The topic is subtracting rational numbers. So if you want to look up any of those videos, feel free and ask me any questions over an email. And I want everyone to have a good and safe day.